Hello there. Let's talk about rational expressions. First of all, we define a rational expression as any algebraic expression that can be written as the quotient of two polynomials. There are some terminologies here that you need to recall. An algebraic expression, a quotient, and a polynomial. An algebraic expression you've seen before. Those are expressions that you replace numbers with letters. So expressions like 2x, 3y, things like that are algebraic expressions. A quotient simply means a fraction. So one thing divided by another thing. But this time, instead of simply using ordinary real numbers, we are going to be having algebraic expressions as quotients in this topic. And the third thing to note is that we are going to be having polynomials in those quotients. So we're going to having the numerators and denominators as polynomials. And polynomials are things like these: 2x, x squared plus 1, negative 3x to the power 4 minus 2x plus 7, and so on. Those are polynomials that you have seen before in your previous study of math. And just to contrast, the following are not polynomial expressions. 2x to the power minus 1, the exponent is negative. Okay, that's why it's not a polynomial. 4 times x to the power 3 halves, the exponent is a fraction, right? Like 3 halves. And then root x plus 2 times x to the power 3 minus 1, the square root of x is in there, right? Because of that square root of x, the square root of the variable makes it not to be a polynomial. So generally, your polynomial expression would have exponents that are non-negative integers. So you are going to have 0, 1, 2, 3, 4, 5 as exponents, and you are not having roots in there and so on, okay, for the variable. So for example, let's talk about some examples of rational expressions. Some of those characteristics I mentioned previously, you will have them here. 2x over 5y is a rational expression. You can see the numerator is a polynomial. The denominator is also a polynomial. Negative x squared plus 3x minus 4 divided by 2x plus 4. That's also a rational expression because the numerator and denominator, they are both polynomials. And 8 minus x cubed divided by 2 minus x squared. That's another example of a rational expression. These are not rational expressions for the same reason I mentioned before. The numerator and denominator, or the numerator and or the denominator is not a polynomial. Like you can see the first one there, 2 times square root of x plus x cubed. You can see that's not a polynomial because of the square root of x. And for the second one, x squared plus 4x minus x to the power negative 3, because of the negative exponent there and because of the radical that occurs, that those will not be rational expressions. And for the third one, because of the negative exponent, negative 5/3, that's not a rational expression as well. Then let's talk about permissible and non-permissible values. Now, whenever you're talking about fractions in rational expression form, where you're having variables in there, you always have to be very, very careful as to what it is you are allowing in the expression. So what we mean here is to answer the question, for what values of the variable is the rational expression defined? In other words, what can the variable not be in terms of real numbers? So for example, you have 4x divided by 1 plus x. What are the values of x that are allowed in here? So we're going to look at a number of scenarios here. So first of all, if x is 0, what's going to happen here? You would have 4 times 0 divided by 1 plus 0. So that means that will be 0 divided by 1, which is equal to 0. What if x is 1? Then you will have 4 times 1 divided by 1 plus 1, which means you have 4 divided by 2, which is 2. But what if x is minus 1? What is going to happen here? Well, something bad happens here. If x is minus 1, you will have 4 times minus 1 divided by 1 plus minus 1, which is negative 4 divided by 0. What is negative 4 divided by 0? I hope you are not thinking negative 4 divided by 0 is 0, because it's not. Negative 4 divided by 0 is not defined. Okay, I like to say that negative 4 divided by 0 is criminal. It's an offense, okay? It's punishable if you divide by 0. Now, maybe later on, we will get to talk about why the division is undefined or why it's criminal. But for now, we will just agree that division by 0 is not defined. If you try to do it in your calculator, you will see that your calculator is unable to perform that division because that is not defined. So that implies then that your x should not take on the value of -1. So, formally then, if we're going to figure out what x cannot become in that rational expression, 4x divided by 1 plus x, we proceed as follows. We would assume, since we already are saying that the denominator cannot be 0, so 1 plus x cannot be 0. So suppose 1 plus x is 0. We have an equation like this, 1 plus x equals to 0, and then we solve that equation. If you solve that equation, you will find that x is equal to -1. That means that when x is -1, your denominator is 0, and your rational expression is defined. So we will say then that therefore x cannot be -1, and x equals -1 becomes a non-permissible value in that expression. Let's look at another example. 3 divided by 2x minus 1. Our denominator must not be 0, like we said previously, which means that if we assume that it is 0, 2x minus 1 is 0, we will solve that equation by adding 1 to both sides. We get 2x equals to 1, and dividing by 2 implies that x equals to 1/2. Now that means that when x is 1/2, your denominator will become 0, which is criminal. You can't have that. Therefore, we will say that x is not 1/2, and x equals 1/2 becomes a non-permissible value in that rational expression. Before we take I ask you to do something else. I've asked you to do an exercise. Let's talk about equivalent rational expressions. Now, this comes from fractions, equivalent fractions. So when do you say that two fractions are equivalent? Well, you say two fractions are equivalent if you can go from one fraction to the other by multiplying the numerator by a number, the same number, or dividing the numerator by the same number. For example, 2/3 is the same thing as 8/12, because you can multiply the numerator 2 by 4 and multiply the denominator 3 by 4 to get 8/12. Therefore, 2/3 and 8/12 are said to be equivalent fractions. You can also reverse this. You can go from 8/12 back to 2/3. All you have to do is take your 8/12 and recognize that 8 and 12 have a common factor. The greatest common factor of 8 and 12 is 4. So if you divide the numerator and denominator by 4, you will get 2/3. Therefore, you will say that 8/12 is the same thing as 2/3. And 2/3 will be said to be in lowest terms. So now, let's apply this to rational expressions. 5x divided by 4y. Well, the non-permissible value here is 0, because since your 4y cannot be 0, if you solve that equation, you will see that y equals to 0. Therefore, y can't be 0 in your denominator. To write an equivalent expression for 5x over 4y, we will for -5x over 4y, we will simply multiply the numerator and denominator by the same numbers. 2 in this case. You could use 3 if you want. But if I use 2, then we would have -10x divided by 8y. That is an equivalent fraction. That's an equivalent form of -5x over 4y. Now, we can reverse this as well. Okay, so we say these are equivalent rational expressions. If we reverse this, -10x divided by 8y, we can simply divide the numerator and denominator by 2, because 2 is the greatest common factor of -10 and 8. If you divide that out, you will just obtain -5x over 4y, like we had originally. And then you will say that your -5x over 4y is in lowest terms. So, why don't you try and find the non-permissible values here? Like we have always been doing, after you can see the question, please pause the video, and then you can try your hand on some of the examples that are there. And when you're done, you can continue the video to see what I have done. So please go ahead and pause the video now. So what did you do? Here is what I have done for those examples. So for the first one there, we just find out that if you set the denominator to 0, you will realize that x cannot be -5. So -5 is your non-permissible value, and you can multiply the numerator and denominator by 2, and you will obtain 2 divided by 2x plus 10. That would be an equivalent rational expression. For the second one, if you set your denominator 4xy to 0, you will find that x and y cannot be 0. Those are your non-permissible values. And you can multiply the numerator and denominator by 5. You will obtain 15y plus 5 divided by 20xy. And for the second one, to write rational equivalent forms there, -7ab divided by 14ax. The greatest common factor there will be 7 times a. So if you break that denominator, you have 7a times 2x. That will give you 14ax. So you can divide out 7a from there. Your result will be minus b over 2x. And finally, you can do the same thing for 10x divided by 20 times x squared. You can rewrite that as 10x divided by 10x times 2 for the denominator. And you can divide out 10x. Your result will be 1 over 2x. This concludes our initial video for rational expressions.